All right. So I'm going to talk about some features that are built into MATLAB for testing and error handling, and then demonstrate how to use the debugger, which is just some tools in MATLAB that allow you to kind of delve into your program and find out what's going wrong with it. You can stop midway through the program, step through it one line at a time, things like that. All right, so first, some general advice about testing. As you start making more complex programs, so we talked last time about how you might have a program that consists of a main script and then multiple functions. And those functions might all be in separate files, or you can choose to use local functions where everything's in the same file. But either way, I urge you, don't just write all this code, put it together, and then try to run it and see if it works. You really should validate each function, each module first, before you try to integrate them. And as you test each module, what are you looking for? Well, first of all, does it execute without errors for every legal combination of inputs? So if any type of fatal error occurs, even though you're passing it valid inputs, something's really wrong. Now, if it runs, that still doesn't mean it's correct. It just means it runs without errors. It may still be giving you the wrong answer. So the next thing you have to check is it giving you the right answer? And that can be hard because you may not always know what the right answer is. That's why you wrote the program, right? To try to find out what the answer is. But there can be special cases where you do know the correct answer. So for example, later in the course, we're going to do mechanics simulations. And there's certain things like drag that make it impossible to do an exact solution. That's why we do the simulations. But what you might do is, well, I'm going to set the drag coefficient to 0 because that's a special case where I can solve for it exactly. And let me see if my simulation gives you the right answer for that case. If it does, then I have some confidence that it's working correctly. Then you run it on more general cases and just ask, is it giving me reasonable answers? And so once I put drag into it, is it behaving sensibly? And sometimes what will happen is you put the drag in and your simulation just blows up because you have a sign error, say. You have the drag in the wrong direction. So it's actually reinforcing the motion instead of opposing the motion, and the velocity will just blow up. And I'm going to show you how to use MATLAB features, specifically assert, and then something called try catch to kind of construct tests in a sensible way. All right, so this is what the assert command looks like. So last time in one of the exercises, we had this function score hand that calculates the score of a blackjack hand. And assert just says, this should be true. Okay. Now, actually, I have these in the code example, so let me go to MATLAB and do them that way. Okay. All right, so this first line is saying, if I have a hand that's a 5, a 7, and a 3, the score should be 15. And similarly, if I have a queen and a jack, that should give me a 20. If I have a king, an 8, and a 4, I should get a 22. So let's run this section, see what happens. Well, it looks like nothing really happened. Well, that's because the assertions passed, right? So this function did give the correct result. So the assertions passed, so it doesn't do anything. If an assertion fails, that's when it does something. Okay, so let's say I have a mistake here. Okay, it says assertion failed. Right, so the function did not return this value. This was false. That's called an assertion failure. And when that happens, it just stops. And so it actually doesn't do the subsequent tests after that if you construct it this way. Now you should always test special cases, something that might not be the normal occurrence, but it could occur in certain cases, like an empty hand. Right? What if your user of this game, the player, so often what you do is you might write a toolkit and somebody else might actually then be using these functions to construct a more complex program. So the person who is writing the overall game doesn't know that he's not allowed to pass an empty hand and he tries to do that, well, it should handle that properly. So if you pass it an empty hand, it should give you a 0. Right? And looks like the way this function was implemented, that worked fine. Okay, now here's another example of an assertion that doesn't work because we're using simplified scoring. We're always counting ace as 1. So even though in a real blackjack game, an ace and a 10 would give you 21, here it's only going to give us 11. So this assertion fails. But the point I wanted to make here is because the assertion failed, it stopped. It never executed this next line. Okay, so if I change this to 11, now the assertion passes, and now it does do this line.